Hey guys, Stephen from Heresy Academy here. The time has come. I mentioned it in the last video. Pretty sure it was the last video. I just said like 7 times there. Right? Okay. Yeah. So I mentioned it in the last video. We're going to get into a decent amount of coding now. The backbone to setting up the bricks. I say backbone like it's supposed to be cool. I don't know. Maybe it's cool. What do you think? Let me know in the comments. Anyway. So straight away, I'm just going to go down and I'm going to make a new C# script. I should call it Brickmaker because this is literally going to make our bricks. So hopefully, if it works, it's going to make my day. I should call it Daymaker. No, it's not. I don't do jokes normally, so I don't know why today's any different. Really, I'm just enthusiastic about the mass amount of coding we're about to do. I say mass amount, you know. We're only going to do a couple of lines, really, but. So it starts, isn't it? Started party with a couple of lines, eh? A couple of lines. No, I thought the jokes would be good, never mind. Right, so get rid of the void update in this because we don't want to use the void update. We want to make our own functions. We can make 2 functions, yeah, two whole functions. We will keep the start function because we will do something cool, pretty sure. Pretty sure we will. Yeah, we will. So where do we start? Right, so what we're going to do is we're going to start with a public game object and we're going to make an array. This array, we're not going to declare a value, we'll set this up in the inspector inside Unity. So the way we do this, we'll start out with public and then go for game object, G for game object. And then to do our array as well, we want to do the square brackets, that's declaring it's an array. So what you can do is you can say 5, so that'll mean you've got 6 objects or 5 objects. Okay, I completely forgot that now. Because you can use 0 in there. So does it include it? Does it exclude it? I'm not too sure. Don't know. Ignore me because I'll just like giving you useless information here. Yeah, we'll leave it blank anyway because we don't need to declare it now. And we'll call it bricks because it's going to be our array of bricks. And then we want to do a public integer, and this will be called rows because this is going to tell us how many rows of bricks we want. Now we won't use this just yet because we'll need it in my second part of the plan, which could possibly be this video or the next video, depending on how long it takes and if I just shut up and get on with it or not, which is very unlikely, and I must apologise. Most likely not going to get on with it. So we're going to go for void because that's what we like to do, and we call this brick setup because this is going to be the function that sets up our bricks. Now, we don't want to put anything into these parentheses. I'm saying that specifically because in the next function, the next void, we do want to put some information in there. So if you see me doing that, make sure you don't mix the two up. Because one's called brick setup and one will be called brick information, brick info. Let's go for brick info. I like that, that's good. Thinking fast. Wasn't really fast. Right, come on. So we're going to actually make 3 floats, and rather than just go float, float and float, we'll make them all within the same one because we're not declaring values or anything like that. And the first one we call screen width, then the next one we will call screen height. That's because we're going to use this information to get the screen height and the screen width. And we will also call this next one brick scalar. So I should have mentioned this in the last one. Pretty sure I mentioned it where I was talking about we're going to basically get the size of the screen, size of the bricks, and we're going to give it permission to scale the bricks if it has to. It depends on the size of the screen. Then we're going to declare an integer, and we're going to call this one columns. I don't know how columns is spelt in the real world. Column. Yeah, no, I'm pretty sure it's like that. I don't know why it looks wrong. Columns. I don't know. Don't care. Because it doesn't really matter what you call it. It's just a reference. So, yeah. We'll declare another float here. But this time, we'll just do it in a single line. The reason we're doing this is because we're technically giving it a value. Although we're not going to give it a number, we'll give it a way to figure out its number, sort of thing. And this will be the brick width. I'll do the same for brick height, but a little bit slightly different. So we're going to take our bricks, our array of bricks, should I say, and all our bricks are going to be the same size. Or they are the same size. You know, the sprites. We've not changed anything. They are, well, they should be the same size. Maybe they're a pixel off. No, pretty sure the same size. Okay. So yeah, our array of bricks, and we put a 0 in here just to sort of index it, saying like the first brick, because they're all going to be the same. Otherwise, you have to do this for every single brick. I'm going to go for get component, and what we're going to do is we're going to use a reference point thingamajig. I'm really not good with my words today. So the component we're getting is a sprite renderer, and we're going to use a function, a feature. Let's go with feature. Let's call it a feature. It's called bounds. Now, if you imagine a box collider around our bricks, okay, imagine that, just the green line around the bricks. The bounds feature that we're using now is essentially like that. Obviously, it's not a collider. It's just basically a boundary. It's telling us the exact boundaries of it. So, like the perimeter of our objects. That is information that is inside our sprite renderer component, which is why we're grabbing our sprite renderer. Although you have got the scale on the transform, this is different information, although it could lead to the same thing. I think an important thing to consider as well, in one of the other videos, was it the ball? No, maybe it was the game edge. Yeah, camera.screen to world point. We're going to be using this again, screen to world point. And I hope I explained it in that last one. Not sure if I did or didn't. I actually want to check this out. So again, just like the last video, basically there's a bit that I didn't understand, so I actually said if you understand it, leave a comment. What's this as well? GameEdge.camera hides inherited member UnityEngine.component.camera. Use the new keyword if hiding was intended. So is this just because I haven't used camera.main? Is that why? Because UnityEngine.component.camera. So because I'm declaring the camera publicly like this, is it just because I've not done camera.main? Let's find out. Let's find out. Okay. Anyway. Sorry, I just stopped halfway through a line there. Okay. So yeah, going back to this, I apologise for just running off there. Going for float brick width equals the array of bricks dot get component sprite renderer dot bounds and then dot size. I want the size of it and then dot x. And that wasn't happy at all. Is it a capital B? No. Oh, come on. Is this not correct? How have I done this wrong? No. Do I have to put a 0 in there? No, don't put a 0. Shoot. Put a 1. No. Leave it blank. Right, okay, this is a bit weird because this is usually correct. Why are we not working? Oh, come on. I really need to wake up. Pretty sure it's because I've not done my parenthesis again. There we go. I apologise, guys. I think I did this in one of the other videos as well. I did the get component and sprite renderer, and I was just trying to move on to the next bit. I mean, I just ran off a minute ago, went to another script, started explaining. Make sure you do parentheses at the end of your more than less than get component, because otherwise it doesn't work, as you can see. So the next float will be brick height, and hopefully I'll remember to do it right this time. Then we'll go for bricks and reference our array, then dot get component. I'm just going to do that. Then dot bounds, dot size, dot y this time. Make sure you do dot y, simply because we're doing the height this time, not the width. Obviously, width is left to right, so that's x. Height is up and down, that's y. And then we'll just write in sprite renderer. There we go. That should change round. That's good. Awesome. And then what we would want to do now. Well, now we want to basically call a function, except we don't have the function here yet. So the way this would work, let's say we're going to call it brick info. Should we go for brick info? Yeah, let's go for brick info. So we'll go for brick info, open our parentheses and do that. Like I said, we're going to put information into this as well. So because we've got nothing yet, it's not going to work. Just to get rid of that red light because I don't like it, we're going to go beneath our brick setup now. and go for a new, what's it called? Come on guys, shout out like Dora the Explorer. No, okay. Brick info is what it's called. No, sorry, it's called a void. There we go. Gosh, I'm really not on it today. I was up all night, and this is the result. Really, you know, I wouldn't say I'm sluggish. I'm just not paying much attention. Okay, so we've made this new void here. So we'll get rid of this now. Why does it not exist? Oh, there we go. Spelling mistake. Huh. Right, there we go. Ah, come on, wake up. Might have to pause this one and make some coffee or something. Right, so our brick info now. This is important, really, really important. So I apologise that I'm not on my game. I'm not on the game or on the ball today. It's very important to understand this next bit. We're going to go with our void brick info, and we're going to put in what's this now? Brick width. We want screen width. We want screen height. We want columns and scalar. So I've just lost count anyway. So brick width, screen width, height, columns. So we want to put 5 pieces of information into here. Very, very important that we get it correct. Okay. So we'll start with a float. We're going to start off with a float here, and this will be brick width. Just separate this. Now the next ones are going to be what we're going to get out of our function essentially, and it's going to call. We're going to write out. So from as an out parameter name, or the interface no, ignore that. So as the form out, then parameter name. So basically, like referencing anything else, you basically tell it what it is, and then write it next to it. Oh, I don't know what's going on today. Then I'm going to stick to floats. We want 2 floats now, and these will be our screen widths and screen heights. I've referenced it, referenced them up there as well. So these will be these floats up here. So another one will be out float screen height, and then we'll go out for our integer. So basically, in this kind of like in this order here, out of our integer, or we can put the brick scalar as well. Forgot that one. So columns, and don't forget the brick scalar like I just did, and do another out float, then brick scalar. Okay, so these are the information that we're putting in and getting out of this this function here. So this is where it gets really important, and this is now what I was talking about a second ago. Is it this one? Yeah. So I'm going to now find out if this error repeats itself by using the other method of calling a camera, because you can put a public camera and then reference it. Another way here then will be just to write camera, and we'll just call it cam because that's what it, this it is. Have I done this already? I feel like I've done this already. I don't know. So what we're going to do is camera dot main. There we go. And what this is, this grabs our main camera within our project. So as you see, it's called main camera, and it's also tagged as main camera as well in the inspector. So when you run the piece of script inside Unity, it'll look for the first camera in your game, which is tagged as main camera, or is called main camera. Since we've only got one camera, it doesn't matter. But let's say you had, what would you have now? A 3D game. You've got a few different cameras set up. Whichever one would be called main camera, this would affect. Obviously, you'd have to consider which cameras you're using and stuff like that. But in this case, 2D game, one camera, that's all we'll need. So camera.main references our main camera. So now the reference point, or the variable name cam, is our main camera from now on. So now we want to find out our screen width. Okay. And to do this, we want to go equals and then open up some brackets. Let's think now. I don't know how many brackets we're going to use. Normally I try and set it up so I've got all the right brackets, but never mind. So cam here now, because we're referencing our main camera. So just like our other one, let's have a look now. Sorry, I just got to jump off. Oh yeah, we called it camera there, didn't we? Right, never mind. I was going to try and make a point, but it doesn't matter. So since we're using our camera, I'm going to now use that screen to world point here. I'll probably write this, I don't know, 2 or 3 times. Let's think now, do you want 2 or 3 times? Maybe 4 times. 4 times sounds good. Anyway, what we're doing with this now is we're going to give it a new vector-free position. Just like when we was using the screen to world point in the other one, we're going to get an X, Y and a Z position, but we only want specific ones. And it's very important to pay attention to this bit. So I hope that I don't mess it up anyway. So a new vector free, and then open some more brackets. And the way that we're going to find out now, find out what the new vectors new vectors are, it'll be, since we're working on the screen width right now, we can use screen.width. Since we're using our camera, it'll recognise what our screen is, and then the width of the screen. That's for the X position. For the Y position, want 0, and Z position, want 0, because we're not going to use the Y and the Z in the screen width. Now close off both these brackets, because that's one thing that catches me out as well, is closing off brackets. But don't close this one off just yet. Okay, so just close off these two. And what we're going to do is we now want to minus another position. So cam dot screen to world point again. And then same as before, we want to do a new vector free. And then open some more brackets. And literally just 0, 0 and 0. Don't do more after that. So now we're going to close that, and close that. There we go, that's free, it's correct. Also it helps as well, it doesn't help, it has to be done. You have to put .x, because we are just working on the X position here. We're not working on the Y and the Z. Okay? So what we're doing is, let me think. I'll explain this part when we get back into Unity, I guess. So screen height here is essentially everything is the same. So try and cut a bit of time now. We'll just drag this, copy it, drop down, paste. Okay. So for starters though, we want to get our Y position. Then the vector frees at the end. We're going to keep these three as 0, 0, 0. But instead, we're now going to get our screen height. So screen dot height, like this. And then again, what we're going to do again is get our screen width position here, and then minus the 0 position here. But don't forget, now we are using screen to world point, so in case you're thinking, well, why are we taking 0 away from this? Because it's going to be this. But I'll explain it better in Unity. So what we want to do now is set up our columns. So again, I'm still not sure on how it's spelled. I think I've got it right. Well, it doesn't matter. If I'm spelling it wrong and you spell it right, make sure whatever you put here is what you called your integer here and here. And also as well, what you want to do is you want to grab this information and put it into the brick info, but we'll do that in a minute. So our columns is going to be equal. This is how many columns we have, so how many lines down. Okay. How many lines down we have? We're going to have our screen width, so don't do capital, just do lowercase. Make sure you get your screen width float. Then you want to divide that by the brick width. Now if you're a bit confused now, if you're going on what's going on, don't worry. We'll just close this. Wait, hang on. These are floats, aren't they? Yeah. What you need to do, put these in parentheses, and like we've done in other situations, it's called typecasting. I don't know if I have mentioned it or not. I think I've mentioned it. We're going to put integer here within these parentheses, and put this in parentheses as well. So screen width divided by brick width. So our screen width divided by brick width, which is this information here. And that is basically telling us how many floats we've got. So after we've done that, we now want to tell it what our brick scalar is. So we're going to go for brick scalar here, and this will be equal to our screen width, and you will divide by, now this is important, put it into parentheses because we want to do this bit first. We'll go brick width, so the width of our brick, then you times it by the amount of columns you've got. Okay. So that's that. I'm just going to save that. Still at the moment it's not going to do anything. We've not told it to do anything just yet. So in the brick info now, we want to basically put exactly the same as what's in the void brick info, but without the floats and the outs. So it's sometimes better just to write it out. So we're going to have our brick width. And then sorry, no, wait, let me just, yeah, said it there. Then you want to do your outs. You do want your outs, but you don't want your floats, if that makes sense. Then you want to go out for your screen width, out for your screen height. What have we got now? We've got columns, brick scaler. Out for our columns. I always forget the brick scaler. I've done this a few times now. Brick scaler. Okay. So this is now grabbing the information. I don't know. I just said. I think I've said it a few times. I just say, okay, you understand? You following? As if you're just going to pop up one day and just go, yeah, I understand. It'd be nice if you do though. If you want to just like pop up in my screen, that'll give me something to remember. So this now essentially is it's the starting part of setting up the bricks. I'm not too sure how long the recording's gone on for now. What we're going to do now in the start area, we want to put our brick setup. So when we start the script, it goes, yeah, this is it's now going to tell it to do this. So we are going to add some more information onto the brick setup now, and this is the part where it should start to sort of make sense a bit. We're going to use what's called a for loop. For loop, not for. I don't ever pronounce that wrong. And what we're going to do, if you've seen these done before, you'll have a bit of understanding. But this is the way it goes. So we're going to create an integer. I'm going to call it x. I'm going to equal 0. And the semicolon. What I used to do with these was an absolute nightmare. I never figured it out for ages. I'd put a comma. I would think I was right, but it's a semicolon. Then we're going to do x, and then this sign. More than less than. Less than, I'm sure it's less than. X is less than, yeah. This is your less than sign. I'm pretty sure it's less than. It makes sense to be less than. Then rows. This is where this comes in. Well, you can't even see it. This is where the integer here comes in now, the rows. So tell it how many rows you've got. I'll explain this when I've written it, because otherwise it may not make sense. Then x plus plus. Okay. So I always see that's one thing as well. I'd always mess it up by putting commas, and then when I figured it out to put semicolons, I'd put semicolons at the end there as well, like as if that made sense. Anyway, so we've created an integer x. Okay, this x is equal to 0, and then the x becomes less than rows, and x is plus plus. So it means you're adding 1 to x. So let's say we've got we tell it we want 3 rows. So x will be equal to 0, which means x is less than 3, and then you plus 1 to x. But then we'll do what's needed in here, this next bit, and then we'll go again. So then x will be 0, x will be 1, which is less than 3. Then you add it, so it's 2. Then you do this stuff again, and then x will be 3. So it'll be less. It won't be less than 3. It'll be equal to 3. So you won't plus it anymore. We do it one more time, apparently. I don't know. Maybe I've got that wrong actually. Should it be more than? No, not more than. Right. Go with it because it works. It's just the way it is. Okay, get over it. So open some curly brackets, and inside the curly brackets now, just to add to our confusion a bit more, we're going to do another for loop, and this time we'll do everything but for y, because we want to. So y will be equal to 0. Y will be less than, but this time, instead of rows, you've guessed it, it'll be columns. Hey, well done, good job. And then y plus plus, so incrementing the y. And then underneath that, open some more curlies. Just to sort of give it a bit of spacing there. And now this is where we start to make the bricks. So, that's not gone blue. Well, it's registered as an integer. Well, that's gone blue. Oh, that's because that's up there, that's fine. And where's columns? Columns is there. Okay, that's fine, that's fine. Yeah, that's because we need to reference that, don't we? Okay. So, just before I carry on with this then, I notice some weird things sometimes, and it's not important. It works. It's right. We've created the integer for columns within this the brick setup function or void. So it's grayed out on my layout. It's grayed out. It might be another colour for you. But the thing I'm trying to point out is we've created rows here as a public integer. The reason for this is because in Unity we can tell it to create 4 rows, or 2 rows, or 3 rows. But as you further develop this game, because I'm not going to mess around and put multiple levels into it, but as you do, you can decide, well, if you've got it on easy, you can decide that the velocity, this one, you could decide if it's easier, the velocity will be not 1 but 5, and then you'll decide that the rows will be 3 or something like that. But when you've got it on medium, you can decide the velocity can be 7, so it's a bit quicker, and the rows will be I don't know, 10 rows if you really want. I don't know, however crazy you want to go. The reason I'm saying this is because then you could get rid of this, get rid of the whole line, and down here, where is it now? For the bricks information, you can put in, I think it's integer in it. So just put in your integer here like this, like columns, put integer for rows, and down here just put rows equals, and then how many rows you want based on that level, sort of thing. But that's not something I'm getting into. Perhaps I could show you a different level system, difficulty system for games, stuff like that. But that's not what we're doing in this one, so I'll shut up about it until someone asks. So please ask, I like it. So we're going to start off with an integer. I'm going to call this our random index because we are essentially now creating a random index. And just to be a pain, move that along. And this random index, I believe we've used random.range for the ball to move randomly, either to 1 and 2, 1 and -1. Sorry. So the same function here. We're going to use random.range, and what we're going to do is we're going to put reference of 0 and what's called bricks, but then dot length. The length there. Gets a 32-bit integer that represents the total number of elements in all the dimensions of the array. I hope that explanation makes sense to you, because that's kind of better than what I'd be giving you. Basically, by telling it bricks.length, you'll essentially be getting the length of the bricks. So it already knows the bricks from here, the game object we put in, or we'll put in afterwards. It'll get the length of that. So the random.range, the random index will choose between the length of our array, meaning, let's think now. I'm not very good at explaining things sometimes. I'm trying to remember where it was now. It was with the ball, wasn't it? Was it with the ball? Random, looking for random. There, random.range. So if I can just get rid of that, perhaps you can highlight for me. No. There. So if you remember, if you do, I'm trying to show you the mouse but can't. So you can see this on the screen now. The float minimum and the float max, and they're both inclusive. If you can remember back to this video, I showed you what the integer one was like, where it was inclusive and exclusive. Because we're using, is it this one? Yeah, because we're using integers now, the first value will be included. So it'll include value 0, and it will exclude value, the largest value, which would be the length of it. So if our array was 5, there would be 5 things in there, but the length would come out as 6 because it includes 0. So it goes 0, 1, 2, 3, 4, 5. So that's 6 digits. But because this is exclusive, it'll go 0, 1, 2, 3, and 4. So even though there are 5 items here, so 0, 1, 2, 3, 4, and the actual length will be 5, is what we set here, so the size of it will be 5, it's exclusive. So if it was inclusive, you have to go bricks.length -1. So, I don't know, I try to explain something sometimes, and maybe I make a big pig's ear of it and I should stop, but you guys can just insult me in the comments, it's fine, I don't mind. At least you'd be commenting, that's something. So we're going to create now a game object component with a capital G, public sealed class. It's very, very official. Why are you spinning back there? You go over there where I tell you to go. The name of our object is going to be called random brick, because that essentially is what it's going to be. It's going to be our random brick once we've set things up. And this will be equal bricks. And then what do we call it again? Random index? Yeah. So this random brick will be equal to what our random index comes out with. And why? I don't understand why you do this. As well, another one, if someone knows how to stop it from automatically deciding to try and format things and move everything along. I like things in a specific way when I code. When I'm trying to do a serious project, yeah, I'll consider minifying the script afterwards, but when I'm writing it, I like it to be laid out like this, and every now and then it keeps trying to scrunch it together, and it really is getting on my nerves. I've come back to monodevelop to do these tutorials in. I normally use Notepad++, so I can just like write wherever I want. I don't have any issues there, so if someone could help me turn that off, that would be superb. So the second object, we're going to go for game object again, and this one we're going to call it new brick. And again, it's moved along. Sorry guys, I'm going to keep pushing it along because that's where I want it to be. And this new brick is it's going to be what's referred to as the instantiated brick. So the brick we have created within the game. So you could write instantiated brick. It's a bit long and might not be spelled right because let's think instantiate. Yeah. So you can do that, instantiate. Anyway. So what this will be now, well actually do you want instantiate? Sorry, my bad. Instantiate. Stop moving back. And what we'll instantiate is our random brick, okay? And the issue we'll have with this as well, it's not really an issue, but we want to typecast this as well. So we're going to go with this. I'm just going to make sure it is a game object that it returns. It doesn't return anything else. We just want the game object. So to explain this now, our random index, which you'll see used here, is equal to a random range from 0 to the brick's length of our array. So let's say we put in 5 bricks. Each one will be given an index number, which will be 0, 1, 2, 3, depending on their position in the array. So it randomly will pick one. So it'll basically randomly pick a brick. So the integer value there yeah, sorry, I had to look at my notes there because I just thought I'd mess them up. It's fine. The integer value here that returns, let's say it picks number 2, then this becomes this here. So brick number 2. So the game object random brick is now equal to whichever brick is brick number 2 within the array. So that could be the red brick or the orange brick or the green brick, whatever brick we choose. So we now create another game object called new brick, and this brick is equal to instantiating a random brick. So the random brick here, so let's follow this along now. So the integer is picked is 2. So our random index becomes 2. So the brick number 2 becomes the random brick. And the random brick number 2 gets instantiated, and you make sure you instantiate the game object. So now new brick equals instantiate the random brick, sort of thing. So when we write new brick, it'll be giving it the command of instantiate this, instantiate that. So if you just automatically instantiate a brick, let's say from them prefabs, it'll put it back to the position it was saved in, which is no good because it'll all just go to one place. So what you want to do now is you want to handle its position. So we'll go for now for the new brick and then just kill the computer because it's putting it back and I don't want it to go there and it's getting on my nerves and I'm going to cry. No, I'm not going to cry, don't worry guys. I mean I might do though. New brick.transform.position. We should have covered transform.position by now. I'd imagine we have. And you know, I really should ignore it, but I can't. It just really bugs me that it doesn't do what I tell it to, and the boss. So the new position of our new brick equals. This is now the bit where the maths comes really cool. It's going to be a new vector 3, although it's still a 2D game, so we're not going to use the Z and all that lot. What we want to do is we're going to minus screen width Okay, this is important. Make sure we get this right. Divided by 2, and then this will be plus our brick width and brick scalar times the y. Is that correct? Where's our y? Let me think. May have just made an error here somewhere. No, it's fine. Actually, it's fine. Yeah, it's fine. Okay, right. Ignore me. So our minus screen width divided by 2 plus, open some brackets here, or parentheses, whatever you want to call them. What do you guys call these? Do you call them parentheses? Do you call them brackets? I mean, you've got like 3 types of brackets, haven't you? So curlies, square. Well, you got angle brackets as well, actually. So you've got like 4 types. So yeah, but I just call these brackets before as a programmer. So you got your minus screen width divided by 2. Then you add brick width, so the width of our brick, which we set up earlier on somewhere over there, the float. I just pointed it with my finger as if you could see it, but never mind. And this is going to be times our brick scalar, so times is the star, which I'm pretty sure you'd know that by now, but if not, then that's what it is. Yeah, so times is the star, the brick scalar, and this will be times y. Don't ask me why, it's the way it is. That's the x position. And then for the y position, we're now going to go for screen height, which is divided by 2, by the way. I'll explain the specific positions and stuff like that when we get back to Unity. Don't think what I've got to explain. I've got to explain why we take away the screen width by 0, 0. Well, take 0 from screen width, take 0 from screen height. It does seem pointless, but it's a legitimate reason. Pardon me. I'm yawning now. I'm yawning. Come on. So screen height divided by 2. Then we're going to minus. Then we're going to minus our block height, the height of our blocks. It's not a block, is it? Brick. There we go. Our brick height times by x. And that is that for the y, and then for the z, we just want a 0. We just want nothing. We don't want a z. Okay. Pardon me. Now, we've mentioned the brick scalar, but we haven't really given it much consideration. What we're going to do now is we are going to mess around with our scale a little bit. Not a lot. We're going to set it up so it gives it permission to scale. Pardon me. I apologise. I'm yawning a lot now. I need to go away. Right, yeah, so we're going to set it up with our local scale, which is the local scale of our bricks. And we're going to basically give it permission to scale if it has to, which I'd imagine it'll probably scale it a little bit, as I tried to show you an example earlier. So very similar to the transform, I'm going to get the transform dot local scale. It's called. Is it still there? Does it still exist? It's not local. There we go. Local scale, and this is going to be equal to a new vector 3. Again, no, not a vector 2 3, just a vector 3. 2D game, what we use in vector 3s, and then we get rid of the z afterwards. So the new brick, then dot transform, dot local scale, dot x as well. Please make sure you put dot x. It becomes times by the brick scalar. If you don't put dot x, you're going to mess up, and you're going to like local scale everything. And then for the y position, we don't want to scale the y position. I mean, we could if we wanted to, but we don't want to today. Well, maybe we do. I don't know. Maybe we do. Maybe that's the one thing I'm getting wrong. So new brick dot transform dot local scale again, and then dot y, and then just leave it like that, because basically the value you've got for the new vector 3, it's saying the new brick dot transform dot local scale times by your brick scalar, which we set up over somewhere. Was it over here? Where did we put as brick scalar? Is it down here? Oh yeah. So the brick scalar is equal to the screen width divided by and the brick width times the columns. So the value of that is now timesing by the transform dot local scale dot x, so the x transform of our new brick that we just instantiated above here. For the y position, we're using new brick brick.transform.localscale.y. So imagine the scale was set to 1, and so the scale of new brick here is 1. So the value that came out of this would be new brick.transform.localscale.y equals 1. So we just give it the exact same value on the y, and then for the z we just give it a 1 because that's what it wants to be. The reason we're not just putting a 1 here is because it could be that we had to change it a bit ourselves. Let's say we wanted to make it a bit taller, so we change it to 1.2 or we want to put it to 1.3. So consider that on your transform, on your scale, if you change the x and the y, the x will be automatically changed now with our brick scaler. If you change the y, pardon me, if you change the y, you'll have to remember what it is. Well, you don't have to remember what it is, sorry, because it picks it up here and then it gives it back to itself. So we close this off and close it off. Pardon me. And this, ladies and gentlemen, should be everything. I'm a bit worried that I've not really been fully focused and possibly forgot something. Let me just think. So reading through it, public game object, so we'll set this up obviously because then it'll do absolutely nothing if we don't. Public integer rows, yeah, that's fine because we'll tell it how many rows we want. Then we tell it to do the brick setup, which is this. So we're getting our screen width, our screen height, and our brick scale, which is correct. Getting our columns, our brick width is equal to the get component bound size x. So the brick width is the x size of the brick. So I'll explain what bound size is afterwards. Hang on a second now. Oh right, no, it's fine. I'd made some notes about the bounds and then dot size, but that's for a different video. That's for the next video, I suppose. Yeah, so ignore me completely. So yeah, the brick width is equal to the x size, which is fine. That's the x axis. The height is equal to the y size. Then the brick info is this. Come on, I don't want to miss something out and then look like an absolute tool on YouTube because I'm tired. Because I just have to do the entire video again, I suppose. I don't want to do that because I should have gone to sleep, but I didn't. That's the life we chose. I'm just looking through, having a quick read. It looks good to me, so just click debug just in case, because maybe I missed a semicolon or something. No, it looks okay there. Oh yeah. So this error here didn't pop up. The game camera, the game.camera. So maybe that's because it wants you to use camera.main now. So anyway, minimize this, go back to Unity, bring it back in. As it loads in, it'll probably take a few seconds to load in. Checking these, so it's telling about load, the application.load level, and that, so that's fine. We'll fix them up another time. So, what do I want to do? Get rid of these bricks now because they're irritating me completely. So, before we do anything really, I'm going to go to the prefabs here. Go to the sprites actually. I did the green one as well, so I'll just drag the green one into the game. Oh, 2 and 2, there we go. Right, so the example here then, what I was trying to explain before is I'd actually scaled these bricks to 2 on the Y scale. So if you just put 1 for this one, the local scale, it'll scale the Y back down to 1 rather than tell you what it is. So this will now register as 2. So this will still give me a new value depending on what it needs to be. And this will register as 2 because that's what it is. That's what it was, sorry. So yeah, this new brick, I just want to check that, so I'll make sure these go the same way. So 2 and 2. Just drag this over here, so well, we don't need to do that, do we? I should call this now. As a matter of fact, please ignore that I've just done that. I'll just drag this back in. I'll do it the old way, just to make sure I don't mess anything up. Just changing the sprite, drag that to the green sprite. Change it to brick 5, like that. Go back to the prefabs folder, drag brick 5 in there. The reason I've done that is because I want 5 bricks. So now I'll get rid of this completely and go to the scripts because we'll have the Brickmaker script. And I suppose we can attach it to our camera again. Poor camera. Drag it onto our camera. And at the moment we've got 0 rows and our size here is 0. So go to our prefabs and I'll just close off the transform on the camera here so we can see it better. And I'll drag in the red brick over to the bricks here. Got to highlight the bricks there, you can't drag it onto that, you can't drag it there, sort of thing. You've got to drag it to where it says bricks. There you got 1, 2. So if you wanted to understand it better as well, or you want to check how many of each brick is in without having to go and count there or whatever, you could essentially rename these now to be red brick, orange brick, yellow brick, etc. But I'm not particularly too bothered. Brick 1, 2, 3, 4 and 5 is fine with me. So I've got 5 bricks and let's say I want, go with 3 rows just for now. This is going to be like a fingers crossed moment because I'm pretty sure I've got everything done. So let's just click play and let's see. No, that didn't work. Okay, wait, I apologise. One last thing. Go back to your sprites. The reason it's done that, I'll explain in a minute because, yeah. Just do it here. Oh no, wait a minute. Go to your sprite editor. There we go, right, okay. My bad. What you need to do is you need to change the pivot. I just completely forgot to do it there. The pivot is this center point. So everything we do, let's say we tell this to go to position 1, 1, 1, it'll put this pivot at 1, 1, 1. So we haven't done that one. Right, so we've done these 5. Yeah. So what we're going to do is click on each one, just click on pivot and click top left. Okay, that puts it in this top corner. That's where we work from our thing. What are we talking about? This is where we work from our equations. So using this blue one as an example, I hope you can see it. I hope the quality is good enough. I'm not bothered about like this blue brick at the moment. So when we tell it to get the width of the block, so let's say it was about there. We divide it by 2, obviously. I think we mentioned that. Well, I must have mentioned it at some point. Then we'll also get half of the brick height and stuff like that. We work it out from here. Yeah, sorry, just trying to move this along a bit. So we get this sort of position in here, and then we do our equation. In fact, I'm explaining it a bit wrong. I'll just drag this along. Right. I'll just drag out another one. Just pretend these are bricks. Okay. Let's just pretend that these are perfect bricks that we've perfectly aligned. Okay. They've come perfectly with our screen. Just pretend that they're all the same size. Which that one isn't, but whatever. So we've taken our screen position and we told it to put a brick here. And the way we tell it to put a brick here is, like I said, we're moving the pivot to this corner. Otherwise, we'll be telling it to put the brick about here. Like you just saw then in that example, all the bricks were up here, weren't they? And that's the very key point is to move the pivot, because now it's going to set the positions from this point. So the pivot is here. So as you watch this circle here, watch this ring, we'll change it to top left, put it there. Same with this one, top left. What you could do is you could tell it to get the value of the brick and divide it so that it only moves. So it'll change the pivot and put in a bit more extra work, and then it'll work again. But it's a lot easier and a lot time saving. I was going to say time consuming then, but no, time saving to just change the pivot of these to top left, because it's just one simple action. I change them all to top left there, top left. Right, yeah, so just M5. Click on apply, make sure you do that, otherwise it doesn't work. And then we'll save it one more time. And this time, let's just see what we do. Pretty sure we got it right now, yeah? Yeah, so what you'll notice, or what you'll hopefully notice, not hopefully, I don't want it to happen, is if I now grab a prefab, oh, I've done it wrong again. Well, actually, you can see it there as well. So you can see the box collider is now off completely, because it was set up to be for the other brick, which means something cool. So yeah, right. You can see the middle of the box collider, the center of the box collider. That is basically where the brick would have been if the pivot was in the center, because that center position of the brick, which is now the bottom corner of this, is the same position that the top left corner of this brick is in. The fix for this, anyway, is to select all of these, and you just go to your box collider on them. Select them all at the same time, so it'll say here you're previewing 3 of 5, whatever, or 5 of 5, whatever it says. It doesn't matter about that. Go to your box collider, click on here, and click on reset. And that'll reset the box collider. Now you see the offset is by this much, and that's the size, and now it goes back to normal. The reason why that's possibly noticeable is because when you come to hit a brick, you might miss, or you might touch the next brick, sort of thing, whilst going through a brick, something like that. So what we'll see, we should see our game working sort of superbly. And as well, now you'll see it's got random bricks. Each 3 times I've just previewed it, it's randomly chosen bricks. Which, if you resort back to the prefab video, the introduction to prefabs that went on for way too long, and I told you it'll be important later on, or I should have told you it would be important later on. The reason that would be important is because instead of doing random, you can set it up to be your pre-designed amount of bricks. But now, just to see, well, I know it works, but just to show you that it works, you can obviously test it out on your own. I'm just going to change this to free aspect, make it a lot bigger, maximize it on play, and click play. And let's see now the wonderful array of bricks appear. You see that? It's changed the scale of them that I was needed. The problem with this, as you look at my paddle, it gets stuck at our confined space, our boundary that we set up, because we've got no way of making this dynamic. So our boundary works within this space because go to the paddle, we set it up there, boundary X, and we've made it a public. Yeah, we made it a public value. Is it a float? Would you say that's a float? I think that's a float. Yeah, pretty sure that's a float. Maybe not. I'm sure it's a float. Anyway, so we made it a public value, and we've manually set it up to be this limit. But what if we do change the screen size? Or if you consider making a game for Android, or even a game for PC, but a game in full screen compared to a game on a small web browser, you're going to have different screen sizes. So in the next video, I'm going to show you now how to set up the paddle boundary. It should be a quick video, a lot quicker than this video, so I apologise this has gone on for so long. It should be a quick video, and it'll basically be a bit of code that will automatically set up the boundary of the X for the paddle. So if we do change the screen size, you'll be able to move the paddle all the way along, sort of thing. Yeah, so that'll be it for this video. Like I said, I apologise it's gone on for a bit too long. I had a couple of issues and a bit of distractions. I mean, I'm completely distracted today, but I'm going to continue recording anyway because we're near the end of the series, so hip hip hooray. Yeah, so that's just the way it is, I suppose. You know, if you made it this far into the video, then well done, good job. You're close to the end of the project now. Tap yourself on the back. By the time you're watching this, the project should be completed because I intend to have the recordings finished today, which today for me is upload day. So if you're watching this tomorrow, they'll be all done. Or next week or next year, whatever. Depends how. It doesn't matter, whatever. Ignore me, please. Well, don't ignore this next bit actually, because this next bit is good. Because basically, I'm just going to say, if you like the video, give it a thumbs up. If you don't, leave me a comment. If you've got a comment on how I just waffle on for ages, I talk about nonsense, and you can still write that if you want. I apologise ahead of time. Well, it's too late to apologise at the end of the video, but yeah, I talk a lot. I try and explain things and then end up getting lost in words, and sometimes make it worse. I apologise for that too. Yeah, just if you fancy it, subscribe to me. I was going to say subscribe to the series. Subscribe to me, and you'll be able to catch up with any of the other videos by going onto the channel, check out the playlist, and obviously you'll get the new videos, you get notification or whatnot, or it pops up on the front of your Facebook, YouTube, stuff like that. So yeah, consider subscribing to me. I know I talk a lot, but you can always put me on mute and just watch if you want. Please don't. But yeah, so thank you for watching. Have a nice day.